Thanks everyone for joining me, and hope you're all having a great afternoon, great second day of Reinforce. So I'm Jim. I work at Snyk, as you probably have guessed by the slides in the introduction. So what I want to talk about today is how we help developers handle security, right? And why it's so important to have developers as part of our security staff for the applications and for the cloud as well. So a big part of this is because the nature of applications themselves have changed, right? Gone are the days when there were specialists who would set up hardware and they knew about the hardware but didn't really know much about the apps. And there were developers who were writing apps and their apps got installed somewhere in the data center and they didn't know much about the hardware that was running it, or they didn't really care. Today, the cloud is part and parcel of the apps. It is the core functionality of a lot of our apps, right? And it's designed with the apps. It provides the services that our applications need. And they're designed in code more and more, right? Things like Terraform and CloudFormation are the things that define how those cloud services are going to work and how they work with our apps and what's allowed to talk to each other and what's not allowed to talk to each other. All of that becomes part of the application design. It's part of the full product view of an application. And there are developers that are specialists in Terraform and specialists in CloudFormation, just like we have Python developers and Java developers. And these developers all need to work together to create a secure application. Unfortunately, and a lot of times, what we see is these things are very much siloed. There are still application security tools that are very much focused on the app side itself and on the developers. And there are cloud security tools that are very focused on the cloud infrastructure services, but they don't know much about the applications. And that breaks this DevOps cycle. You go to every booth at this show, and probably somebody has some version of this DevOps infinity loop, right? Including us. But the reality is that it's broken because we haven't really connected this thing full cycle yet. We haven't connected the code to the cloud yet, and we haven't connected these teams to each other yet to treat things as a full product that we need to secure. What we want to do is remove that barrier, right? If we're going to really do DevSecOps, we need our developers and our security teams and our operations teams all singing the same tune. We need them all on the same page, right? And we need to be able to actually create this feedback loop, right? Actually create an application, deploy it to the cloud, get feedback from the cloud that we can use back and develop and make our application better. And that includes the security of our application and the cloud services that application is using. Now, I'm assuming that most folks that are here are the security teams, right? You're the security experts at your organization. And you feel this pain significantly, I would assume, as well, right? Where there are far more of the developers than there are of you, right? And this creates another problem. We get all kinds of alerts. We get all kinds of issues that pop up. We have AppSec tools and CloudSec tools that show us all these problems. But as a security person, if it's written in code, it's part of the application. You can't just go change things, right? Somebody else has to go and fix all of those issues. You're responsible and accountable for the risk overall, but the developers are the ones that are responsible for actually changing things, right? Because if you change it and do something wrong, it could break the application, and we can't have that either. We also know that there's a lack of security expertise, right? There are loads and loads of open security roles, but there are enough security experts to actually fill those roles. And so the only way we're going to be able to solve that problem is to bring people into the security fold, right? We have this problem where we have 100 developers on average to every one security expert. If we can make those developers, enable them, empower them to handle security, right, then we can solve some of that security gap problem that we have. With application security, what we've done is we've shifted left, right? Everybody in the application security world is talking about shifting left and further left. And with Snyk, we really sort of pioneered that, making sure that developers actually could take that security output and know what to do, right? They may not care about all the details about a CVE and all the information behind it that a security person cares about, but they do want to know how to get it out of their code, right? What is the line of code I need to change in order to make that go away? And so by shifting left further and further, all the way back into the IDE, we can help them fix those issues even before they commit their code into the repo. When they commit it to the repo and they want to merge their code, we can check it there. We can check it in the pipelines and on, right, to make sure that we're handling those vulnerabilities and that the developers can take care of them way before it gets to production, right? Once it gets to production, then we try and go backwards to the code. It's a insurmountable challenge, right? I've had hard enough time trying to figure out who the development team is that owns the code, and then trying to figure out where in the code we went wrong once an app is running is a big challenge. And so we want to shift that all the way to the left and make developers able to handle those things very early. The great thing about the cloud and starting to use infrastructure as code and containers and all these technologies, aside from all the benefits of the cloud, like you know, and the scale of the cloud and all those, is that we can actually apply those same principles to the cloud, right? The cloud is code. It's all software. We're using an IDE of some sort to craft our configurations. We can check those configurations in that IDE. We're checking them into Git repos. We're pushing them through pipelines. All of the same security principles that we've used to make our applications more secure, we can use with the cloud as well, right? And so this is an important concept, and you hear about code to cloud and being able to cover all of these different sort of areas where our cloud is actually defined. But it's even more than that, right? There are a lot of tools out there that will check your IAC and tell you whether you've misconfigured something. And there are lots of tools that are out there, and they're out here on the show floor, that will check your cloud and tell you if the cloud is wrong. But as a developer, what happens is you get two different alerts that come in, right? And they might say two different things, and you don't know which one is right and which one is wrong. What we need is a unified policy engine, right? We need to be able to check across all of these environments with the same policy and get the same result. So as a developer, I know exactly what's important and what to fix. The cloud also provides this really important context to me as a developer. If I scan my IAC code, I'll give you a quick example. If you scan it and you have an S3 bucket that's configured in IAC, right? And you've got a public ACL on that S3 bucket. Every IAC tool in the world is going to tell you you've misconfigured your S3 bucket, right? But there's a setting in AWS that you would set in the cloud, right, that says ignore all public ACLs. So if you're only looking at an IAC, you're going to get a red flag that says that's a problem. If you're looking at the cloud, you're going to say there's no problem here. As a developer, which one's right, which one's wrong? You need that feedback from the cloud. You need that context that helps you see that that issue that you have, while it's something you probably want to fix, it's not a critical issue, right? On the other hand, if that S3 bucket is publicly accessible to the internet and it's got a public ACL on it, then you have a critical issue, and you need somebody to go and fix that immediately before data disappears, right? Same thing with drift, with unmanaged resources. There's a bunch of things that we probably have running in the cloud that we want to move into infrastructure as code. So we have this auditability, we have this ability to check it, and we need to be able to see those things as well. So the cloud is an important area to provide context back to developers. That's what we call going from code to cloud and back to code, right, to fix things. The code is the source of truth. It's where we should apply our fixes, and it's very much a developer problem. But again, we don't want to have our apps and our cloud be two separate and distinct domains, because they really are part of the same, product at the end of the day. They are our service altogether. And the cloud also provides important context back to the application as well. We can have tons of vulnerabilities in our application, but if there's firewalls that block people from the network access required to exploit those vulnerabilities, then maybe they're not as critical for people to fix. We don't have to stay over the weekend. We can come in on Monday and fix them, as opposed to making it immediate. So it's really important that we have these things together as a complete view, and that the cloud is used for context for all of these issues. Walk through a quick example here. Log4j, Log4Shell, which everybody I think is intimately familiar with, but really talk about what does it mean to have something that a developer can do about Log4j, right, or Log4Shell. If we have a cloud security tool, cloud security tools are going to be able to tell you that you have Log4Shell vulnerabilities in your apps. Most tools will be able to give you that information. What a cloud security tool will tell you is where it is, what region it's in, maybe a container name, maybe an application name, right? That will sort of help you identify the right team. It'll give you the CVE information, like the CVE ID and what version of Log4j will fix it. But is that sufficient for a developer to actually do something about it, right? What a developer needs really is they need to know what line of code has to change and what does it need to change to. The CVE fixed in gives me what I need to change it to, but it doesn't give me the line of code as a developer, right? So I have to have that deep application intelligence. And it's not as simple as just going and looking for Log4j in my code. With Log4Shell, 60% of the cases that we saw at Snyk were indirect dependencies, right? I didn't add it as a developer. I added something else, which somewhere in its dependency tree had log4j buried in it. So I can't just go change the version of log4j. I have to change the dependency that I added to something else. And that's a far more complex problem. So what a developer ends up doing is wasting a lot of time Googling and digging through dependency trees to try and figure out what things are broken and how to fix them, when we could just tell them if we had the right tools, and they could just make that fix, or we could automate it if we really want to push that far. And so that means putting it into their tools, right? It means putting it into the Git repos, putting it into CI, putting it all the way back into the IDE that says, this is the line of code right here that needs to change, and here's what you need to change it to make this vulnerability go away. And then we can push it back through the pipelines. Or we could just open a fixed PR for them, create a branch, put the PR in there, let them test it, and push it back through the pipelines if we want to automate everything for them, right? That's what we need to help a developer be able to fix these issues. So as security people, we can get that off of our plate, off of our backlog, and take care of it. Drift, we talked a little bit about the S3 bucket, but Drift is another very similar concept, right? I need to be able to see everything in IAC and scan it and look for vulnerabilities, but I also need to find things that have drifted. And sometimes drift is okay, right? I have applications that scale up and scale down. Well, that's a form of drift, but that's known and good, and it's fine that we have that sort of drift. Other drift is bad, right? There are resources that somebody goes through and they opened up a port so that they could copy some files over, and they swore they were going to close that port when they were done, and then they forgot. And so the ports are open, and we have services that are exposed to people. Well, we need to fix that, right? We get to a point where our IAC is so far away from our cloud that the things don't work anymore, right? And so we need to be able to identify those and fix them, and then find those unmanaged resources, get them captured in IAC. Or if they're not going to be captured in IAC, we still need to apply that same security policy to them, right? So that we have all of those resources secured. So critical that we do all of those things. It's critical that we bring all these together, right? The code in the cloud, all the developers that are involved with this, all the security teams are involved with this, so that we really can provide this DevSecOps process. And that's what Snyk has been focused on, right? That's what our products and our Snyk's developer platform does. We've got demos at our booth. You can go see it if you want to see these things live and see real examples of this. We'd love to show it to you. Snyk covers everything from the code that the developers write in multitudes of languages, right? The open source packages that they are adding to those applications. If you're putting things into containers, we'll check the containers and help the developers choose better and safer and build better containers overall. And of course, IAC and cloud, so we get that full view of the cloud infrastructure. All of that data back into one place so that we can see our application as a whole, right? So if you want to find out more about Snyk, we've got lots of resources available. We've got lots of resources at the booth. We have experts. We actually now have beer and pretzels at the booth. So if you don't want to learn more about the software, there's another reason to go over to our booth. But hopefully we can tell you a little bit more about Snyk as well. You can also get Snyk through the AWS Marketplace. And so if you want to get a hold of it, you can. You can sign up for Snyk for free and start using any of the products that are up there and give them a shot. All right. I appreciate it. If there's any questions, I'm happy to take them, or I will be over at the Snyk booth. We have lots of experts at the Snyk booth. Have a great rest of your show.